Hi, my name is Bruno and I will show you how to use LCVplants R package. Currently, biologists are faced with a challenge to put together and combine several databases. The problem occurs due to taxonomic mismatches. Faced with this problem, scientists put together the LCVP database, which is a new taxonomic reference list for all known vascular plants, and it includes more than 1 million scientific names. You can readily use the LCVP database using the new R package lcvplants. For example, you can harmonize species named lists. You can also use LCVP group search, for example, to search all species by taxa or authors. LCVP match function also allows us to match and compare two name lists, or directly join two tables using LCVP join. So let's go through on how to use the LCVP package on R. To install lcvplants, we need first to get DevTools. Run this code and it will download the DevTools from Chrome. Then you just need to load DevTools using library. Okay, now that we have DevTools loaded, we can download the LCVP directly from GitHub. LCVP is the data package that contains all the information necessary to perform the taxonomic harmonization in vascular plants. Use the lcvplants package. We're going to install it from GitHub using this path. So just run this code. It will install for you. Once it's done, now we can finally install lcvplants. For now, we can only install it from GitHub, but we hope it soon you can install directly from Chrome using install.packages. Now the installation is done, we can move on and check the main functions of lcvplants. To use lcvplants, first we need to load it using library. Just load the package. The main function in lcvplants is the LCVP search. The input of this function is just a species name. For example, here is Hibiscus vitifolius. Once we run the code, it will search into LCVP database for this name, and we can actually see the result here using view. So you can see the full output. So the output will show us which was the input used by the user, the search. The input taxon matched in LCVP database. The status of the name here is an accepted name. A plant list comparison, so it is identical to the one in LCVP. Whether it has a plant list alternative name, and the actual output taxon, which in this case is the same as the input taxon because it's an accepted name. Also, it returns the family and order of that species. Well, we can also, LCVP search can also deal with misspellings. For example, here, instead of vitifolius, we have vitifolius. So let's use the max distance equals to 0.1 and see the results. Notice that LCVP search now gives a warning because more than one name was first matched to Hibiscus vitifolius, and only the first accepted name was returned. So let's check the result again using view. And we can see now that the search was a misspelling, but still matched the same input taxon as before. If we want to check all the results matched for Hibiscus vitifolios, the wrong name, we can use, instead of LCVP search, the LCVP fuzzy search. So we can use the same arguments. And let's check the result now. Now we can see that besides the main species here matched, we also have some subspecies matched as well as some varieties. So you can check everything here. Some of them are accepted, some of them are synonyms. Notice that in the LCVP fuzzy search, we can also define the status that we want. For example, we could just want the accepted names. So right here, accepted. Let's run again the function. And notice that now it will only result the fuzzy search that matched the accepted names. Okay, LCVP search also allows us to perform search for multiple species. For example, here we have several species of hibiscus, of the hibiscus genus. I will create this vector named SPS, and we will use it as an input of LCVP search. Okay, now that's done, let's check the results. You will notice that all the species were matched. Here are the same results, but now for all the species that we searched, the result is this data frame, same as before. And now that we have a performance for multiple species, we can also use on the result of the search the LCVP summary, which summarizes the results of the search. For example, here we searched for 4 species. It matched 100% of the species searched. All the species were exactly matched. No one was fuzzy matched. Now, let's see what happens, for example, if we add hibiscus vitfolius here that requires a fuzzy match, and we go again, perform the search. It gives the same warning as before, because more than one name was matched for this name. And you can see again that we matched all the species, 100% of the species, but only 4 of them were exactly matched. 1 was fuzzy matched. And since we just inputted for the 2 first species here, the outer names, 2 of them were exactly matched. And infra categories matched was 100%. We searched for some with the variety and the others without varieties. Okay, so let's see now how can we search based on groups or authors. LCV Plants package also allows us to search by author name, for example. For this, we can use the function LCVP group search. Notice that we use the author abbreviation used by the botanical nomenclature. So here we're going to search the species described by Rudolf Schlechter. For this, we just use the author abbreviation here. We have to define the search by, which in this case is the author search by. We want only the accepted names. So we're going to run this code and let's see the results. So you may notice that the output is pretty similar to the one before for LCVP search. We have the input taxon, the status, the plant list comparison, a plant list alternative, the output taxon, the actual accepted name here, the family, and the order. Here currently the LCVP group search allows to search by author, by genus, by family, and by order. So let's search by genus, but now let's use more than one name. For example, here, let's use these 2 genus names. I'm creating a vector named genus. and I will perform the search. So once we have more than one name searched, we can decide whether to bind the results or not. For example, in this case, I have bind the results, so the result is only one data frame with both species for both genus. Let's go back and see now. When we turn this into false, we're gonna have now actually a list with data frames per genus. Okay, so here is the data frame for AA, and here the data frame for Andosia. You can also check here. I will clean my console, and we can have here genus search. We can use the dollar symbol to get data frame for each of the species of the genus. Here for AA, and here for Andosonia. Now let's check how we can use lcvplants to compare two species lists. lcvplants can also be used to compare two lists of species name. For example, here, let's just generate two lists of species name that overlap a bit. So here we have species list 1, and here we have species list 2. We can use the LCVP match to compare these two lists of species name. So I will run this code. So once the match is done, let's check the results. You can see the results. We have here the species in list 1, the match of the species name in species 2. Notice that the order of this table is based on the species list 1. And then we're going to have the LCVP input taxon matched for both names in both lists. The status of the name, the actual output taxon, the valid name now. And we have the match position. This indicates the position of the name in species list 2 that matched the name in the position, the first position here, and whether this has an duplicated output position. For example, here, these species are synonym with the species in the line 76. It's also important to show that names that are only present in species list 2 appears here as NA. You would also see an NA here if no name in species list 2 match the species list 1 as well. You may opt not to include the species in species list 2 that didn't match any species in species list 1. So in this case, for example, let's also see the result here. So let's see the result. You may see now that the species that only appear in species list 2 are now not included in the results here. This is useful when you want to reorder the species list 2, for example, to match the species list 1. Then you can just use, for example, the column match positions 2 to 1, to reorder your vector in species list 2, so it matches exactly the same positions in species list 1. One useful tool in lcvplants is lcvp join. It allows us to join two data frames based on the species name that are harmonized using the LCVP database. For example, here, let's create two data frames that we may want to join. Here, for example, table 1. Let's see table 1 here. So it's basically one column with species name and let's say a trait 1, for example, a continuous trait here. And let's create a data frame 2, table 2, that contains some different species, may contain species that are within species list 1, and species list 1 may contain some species that are not in species list 2. So let's see how table 2 looks like. Okay, it has a column with species name and some other traits, some continuous, like on table 1, and some traits that are categorical, or for example, could be a logical character, whether a species is present or absent in some location, or whether it has some trait or not. So let's say you may want to join table 1 with table 2, but notice that not all species in table 1 are in table 2, and vice versa, and they may not be as well in the same order. So LCVP join makes this job easier for you. The first argument needs to be the table 1, the second argument needs to be the table 2. Then you need to define which is the column in each of the tables that has the species name. For example, here in table 1 and in table 2, the column with the species name are named species with the S capitalized. And the type here is full because we may want to keep all species in both tables. So I will run the code and let's check the results. So you may see here the name in species list 1, the name in species list 2, the actual matched name in LCVP in database with the input taxon matched, the actual valid name for the species, and the traits for in both tables. So they are joined. Notice that here, for example, the species in list 1 were not present or didn't match any name in species list 2. And because of that, we input NAs here. Okay, so this is the full join. It will keep species in both tables and maintain and insert NAs where it didn't find in one or in another table. You may want to change the type of match. For example, you can have the type left. Type left will only keep the species in table 1 and try to get the values from table 2. Okay, so species that are only present in table 2 are discarded. It looks like the same, but it doesn't have species that were just present in table 2. The inverse of this is right, type right, and if you want only species that are present in both tables, you may use inner. So let's run inner here. Notice now that species that didn't have a match in species list 2 is now absent from this table. One issue that is still present here is that the input taxon may be now a synonym with another row here in this table. So you may have duplicated output taxon. If you want to automatically solve for that in LCVP join, you may insert solve the duplicated equals true, and it will try to summarize for you the traits. For example, here species here were combined, so it took the mean for trait 1, trait 2, trait 3, and it combined the trait 4 since it had both A and B. And for trait 5, if it had any of the rows had true, it will keep true here. If all of them were false, it will keep false here. By default, of course, but you can also change the functions used to summarize each of the trait category. If you want to know more about that, take a look in the LCVP join help file. You can change function numeric, so you may want to use a median. You may change function character. Instead of keeping all, you may keep only one of them. function logical. For example, if instead here we are using any, if any of them are true, it will keep true. But you could use, for example, all, the function all, that will only maintain true if all of them are true, etc. You may also use a custom function to summarize the traits as you want. Okay, so hopefully the package will be useful for all of you. I hope you enjoy, and if you have any doubt, don't hesitate to contact us and or report any issue on our GitHub page.